All right, we've seen how to write electron configurations using the kind of boxes that we had written out in the diagram, or using the following orange kind of chart. And you'll recall that we could solve for electron configurations of things like, say, oxygen on the periodic table by considering the number of electrons within it. For example, oxygen has 8 electrons, so you would say that its electron configuration was, well, let's see, you could fit 2 electrons into 1s into it, so you would say 1s2. Then you would fill the 2s with those 2 electrons, 2s2. Then after the 2s, you would fill the 2p. 2p, but how many electrons would you have that you could put into the 2p? Oxygen has a total of 8 electrons. You've already used 4, so you can only put 4 more in, so you would say it ends in 2p4. So this is the electron configuration of oxygen. But I'd like to introduce another way to solve for electron configurations instead of using this chart, and that is just to use the periodic table. You see, the periodic table is organized in terms of the subshells that electrons are going into, the most recently filled electrons are going into. So you'll see that hydrogen has an electron configuration of 1s1, and then helium has an electron configuration of 1s2. Then lithium is 1s2, 2s1. So hydrogen and helium, they were in this S block. They were filling in the 1s subshell, and then lithium right here, it filled the 1s subshell, and then it started filling the 2s subshell. And then beryllium did 1s2, 2s2, and then boron next was 1s2, 2s2, 2p1. You see the most recently filled subshell, 2p. We knew that that would start being filled for boron because boron is in the 2p kind of row here. Actually, yes, or kind of period. You see, it's in the p block. Okay, so we've got the S block in pink here. We've got the P block in green, D block in blue, and F block in brown. Boron, its most recently filled subshell is it should be 2p. You know this because it's in the P block, and it's the first group within the P block. And then next we have carbon, that would end in P2. We have then nitrogen, that would end in P3, and oxygen, that would end in P4. Yes, we've already seen that the electron configuration is 1s2, 2s2, 2p4. We could have predicted that it was 2p4 just by its position right here, the 1, 2, 3, 4th column in the P block. So we could have just said the electron configuration of oxygen is 1s2, 2s2, 2p, 1, 2, 3, 4. How about if we had wanted to name, say, bromine? What would the electron configuration of bromine be? Okay, so we start at the very top left. We go, okay, fill out the S block. So 1s, 1s2. Then we fill out the 2s. So we say 2s2. Why 2? Well, there's 2 columns there in the S block. Then 2p, 1, 2, 3, 4, 5, 6. 2p6. Then we're kind of going left to right, left to right. After the 2p, we do the 3s, so 3s2. Then after the 3s, we fill the 3p, 3p6, 1, 2, 3, 4, 5, 6. Then the 4s, 1, 2. Then strangely, right after the 4s, we do the 3d. These are kind of weird because here, even though in period 4 we're filling out the 4s and the 4p, we actually fill out one less than that. So we take that period number, and then we subtract 1 to say actually the period number, well, actually the principal energy level for the D block here. So 1 less than the period number. Okay, so we're filling out the 3D, and then we'd say 3D10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we'll do the 4P. Bromine is right here in the 5th column. 1, 2, 3, 4, 5. So we would say 4P5. So that is a quick and easy way of doing the electron configuration for something. Instead of using this whole orange chart, we just look at the periodic table and just kind of say what we're filling out. Okay, let's try another one. How about we fill out, how about neodymium right here? All right, so neodymium. Okay, so fill out 1s. All right, 1s2, 2s2, 2p6. After this 2p6, we do 3s2. Then we do the 3p6. Then the 4s2. Then the 3d10. Wow, there's so much. 3d10. Then the 4p6. Then it's 5s2, 4d10, 5s2, 4d10, 5p6. Then after the 5p6, we do the 6s2. And then, right after the 6s, it's kind of a special place where we actually have to veer down into the F block. After the 6s, after the 6s, we fill out the 4f. So that is actually down here. So 4f3. Yes, it's weird. The periodic table really should be looking like this. This is how the periodic table should actually be arranged. However, because the F block takes so much room, and we so rarely use it, we actually took it from here and we moved it all the way down to the bottom. So the 4F actually belongs right here. Okay, so after 6S you fill out 4F. Weird, it's in period 6, but we're filling out 4F. Yes, when you're filling out the F block, the principal energy level is always going to be 2 less than the period number. So you're filling out 6S, then you fill out 2 less than that, 4F. You're filling out 7S, then you're filling out that 2 less than that, 5F. Thanks for watching, guys.